The fauna. All animals living, breathing, consuming, and roaming in their respective habitat. From high-flying birds to deep-sea fishes, from slithering reptiles to versatile amphibians, from hairy tree-climbing primates to quadruped plain-roaming mammals, all contributing to the richness of the bioverse. We call this richness biodiversity. Along with the lush plants, gut microbiome, and all other living organisms, the animals coexist in a dynamic and sensitive ecosystem, each interconnected as nodes in the food web and as agents of different movement of materials, including carbon.
Carbon, the sixth element in the periodic table, can form versatile compounds by establishing four bonds with other atoms. From the biological blueprint to essential chemicals for animal survival, the carbon-containing organic compounds brought order and beauty that we call life, and is essential in proliferation. For life to survive, an animal hunts for prey and consumes its carbon-containing meat, digests the organic compounds, metabolizes them into simpler forms, and utilizes the energy received. Eventually, excess carbon is expelled through respiration as animals exchange carbon dioxide for atmospheric oxygen, a crucial material for energy metabolism. The released carbon dioxide joins the vast atmosphere, embarking on various journeys, entering a plant for photosynthesis, be dissolved in the ocean, be deposited into carbonate sediments, or stay with the dead remains to be buried and undergo several processes and turn into crude. Regardless, this six-proton adventure will see itself trekking a loop through animals, atmosphere, hydrosphere or lithosphere, and back again to life. This is the carbon cycle, and it is normally in equilibrium.
Ironically, the element of life also becomes
Just an emergence of bipedal primates has resulted to disruption of cycle. Since the Industrial Revolution, the need for rapid mass production and high energy consumption has increased across households, industrial plants, and institutions. Since then, burning of fossil fuel had been humanity's main energy source, and we became more dependent on it as we entered the plastic era. Plastic polymers are oil-derived, after all. The burning of fossil fuel, the production of plastic materials, and the slow decomposition of plastic waste in landfills make up much of the human-induced carbon emissions, both in the form of carbon dioxide and methane. Our exponential industrial development over the past century had intensified the carbon that is being released into the atmosphere, thereby disrupting the cycle.
Naturally, the greenhouse on Earth may feast on the greater amount of roaming carbon. However, expansion of industrial and agricultural lands enabled mass deforestation, and thus we lost more than half of forest lands in the Philippines alone. With no natural carbon sinks, nature must find another, such as by acidifying the oceans. The current decline of alkalinity of marine habitats by a little more than 0.1 in the pH scale, which is about 30%, have already affected aquatic life, resulting in gradual biodiversity loss in deep oceans near the poles.
We have not scratched the surface of this issue that much yet. Carbon dioxide and methane are powerful greenhouse gases, trapping heat in the atmosphere and increasing our global temperature by about a degree Celsius annually. Global warming could be the most predictive factor for climate change. Intense hot and cold climates and severe weather came along, breaking records in recent years. Think about the animals. No, think about yourself. What can proliferate now?
Let's play a game. Epigenetics, a game of developing traits independent from the actual gene sequence in the DNA. Here's the mechanics of this game. Gene expression, representing an organism's characteristics, can be controlled by internal and external factors such as environment and lifestyle. No, this is different from mutation, where you modify the DNA sequence, but rather, you can only silence some part of it by manipulating some outside factors. For example, you can continuously expel massive carbon waste in the past era, unaware that you are playing God. Then, you'd alter the biodiversity not just by species extinction, but by alteration of their traits. Your carbon emissions contribute to stunted plant growth, impacting agricultural productivity, while in animals and humans, your air pollution induces various epigenetic changes linked to cardiopulmonary diseases. Our tech advances can help us cope, sure, but not the rest of the animal kingdom. So, are you up for this challenge? Will you be the most invasive?
Rising atmospheric carbon dioxide levels, key driver of climate change, has been shown to boost photosynthesis in some plant species. This increased photosynthetic activity can fuel the growth and reproductive success of plants, giving them a competitive advantage over native species. We thought green was always beneficial to the environment, but excessiveness is always detrimental. This is illustrated by the American bullfrog, a seemingly harmless amphibian turning invasive, thriving in damp places, consuming insects and hibernating in cold weather. Their green camouflage becomes a weapon in new habitats. But what made these tenacious aquatic beings an invasive species? Since the dawn of life on Earth, species migration and colonization have threatened biodiversity, ecosystem stability, and vital functions. Invasive species, marked by non-indigenous status, adapt rapidly to new habitats, exhibit higher reproductive rates, and endanger other species. For some intruders, they thrive and dominate because of the absence of their natural predators in the newly colonized area. A proactive strategy to eliminate invasive species is to preemptively halt the introduction of new species, commonly employed in pest control.
The prevalence and detrimental impacts of invasive species stresses the urgent need for proactive and collaborative efforts in their
An equilibrium of matter in the ecosystem disrupted by anthropocentrism and our need for domination. Hence, our actions become catalysts of imbalance, from materials to traits and even to key species.
Definitely. We can still reverse this, right? How about we start by changing our consuming behavior in a way that we reduce our consumption of energy and plastic, and consequently carbon emission.
Will you take the challenge to discipline yourself through proper monitoring of energy usage and opting for eco-friendly alternative products?
How about the industry players? Will you ever find new methods, processes, raw materials, and products, both ethical and sustainable, in exchange for your short-term inconvenience?
We have already started, yet we still forget. So, let this final question, resolvable in years we won't possibly reach, become your lasting worries. Who will you proliferate?
Order or chaos?
Green or green?
Beauty or dullness?